Okay, example 2. This is the decomposition. Okay. Write the partial fraction decomposition of each rational expression. So the first thing we have to do is we would need to, let me make this, we would need to factor it out when we can. So this is x squared minus 5x plus 6. On the bottom, it will be x minus 3 times x minus 2. And yes, I do expect you to factor out. Now, the formula says when you have non-repeating linear, then it's going to be a over the first factor plus b over the second factor. Okay, so based on your formula. So your job is to find out, okay, what the numerator is. We'll box this up for both fractions. Okay, we'll box it up, we'll come back, we'll fill that in. So I'm going to, because this is your first time, I'm going to write down the steps. Step 1, get rid of fractions. Get rid of fractions. Okay, so I'm going to have, so you have this x over x minus 3 times x minus 2. It has to equal to this. It has to, okay? So your job is to find a and b to make this true. So the first thing I'm going to do is I'm going to multiply everything by a, ooh, this is bad, by a common denominator. Well, they both have x minus 3 times x minus 2. So that's what I'm going to do with each. Multiply this by x minus 2 times x minus 3. What you multiply to one term, you have to multiply to all the terms. So get rid of fractions. To get rid of fractions, you multiply by a common denominator. Well, when I do that, these denominators are gone. When I do that, those two are gone, and these are gone. So you're left with x on this side. On this side, you're left with a times x minus 2. X minus 2 plus b times x minus 3. So notice how when the fractions are gone, it's a lot more simplified. Okay, so next you will distribute, substitute, distribute. Okay, distribute. So you will have x equals ax minus 2a plus bx minus 3b. And then step 3, you are going to group all the x's together. Okay, group like terms together. Group like terms. Okay, so on this side, I still have that. I have x's, so this ax plus bx, and then I'm going to have a minus 2a minus 3b. Then from here, what you need to do is put quantity around these. And this one, you can rewrite this, okay? Technically, this is you can do that, okay? So you can put quantities around that and factor out. So step 4, factor, okay? Well, so left side, I still have x. This has a common of x, so you have a plus b. This doesn't have anything in common, so you're going to leave it as is, okay? And leave it as an addition. Now, what happens is on the left-hand side, technically you have 1x plus 0 constant, okay? Over here, you have a plus b is the x, okay? Then your constant, okay, is 0, but that is negative 2a minus 3b. So what you do is you're going to take them and you're going to set them equal to one another. So 1 equals a plus b, then 0 equals negative 2a minus 3b. Okay, yes, that's exactly what you do. Now I'm going to solve this. You can use matrix C, you can use algebra. I'm going to use algebra. I will go in and multiply this by 2, so I can use elimination system. Okay, when I multiply that by 2, I now have 2 equals negative 2a minus 2b. So why did I get minus from? Oops, this is positive. All right, let's try that again. 2a plus 2b. Okay, so when I use elimination, the a's are gone. So when I add 2 equals negative b. So that means b is negative 2. So I got that one down. If b is negative 2, I can plug it back in here and solve. 1 equals a plus negative 2. Then it means a, add 2 to both sides, equals 3. So I have a, I have b. Now my decomposition comes down to a is 3, b is negative 2. And that, class, is your partial fraction decomposition. Let's move on to example B. And again, just like earlier, you're going to try to factor if you can. So this is x plus 2 all over. Factor this out first. I see that I'll have an x in common. So that means x squared minus 2x plus 1. Now I'm going to try to see if it's still factorable. Okay, so this is going to be x. Then this is going to be an x minus 1 twice. Well, x minus 1 twice, class, it's actually written as x minus 1 squared. So this is a linear repeating, right? Repeating means you have more than one of those. So based on your formula. So not only have a linear that's repeating, you also have, so this is kind of putting two together, a linear that's not repeating and a linear that's repeating. So based on the formula, a linear that's not repeating is just a over this first. And then if it's repeating, you do b over, based on your formula, b over x minus 1 plus c over x minus 1 squared. Okay. If this x wasn't here, then this is gone. Okay. Then this is a and this is b. But because we're trying to combine multiple concepts together, this way you know what to do. So your job is to find a, b, and c. We'll just box our answers here once we have done finding our a, b, c. All right, just like earlier, your job is to clear out your fractions. So here we go. Let's write it over again. X plus 2 over x times x minus 1 squared equals a over x plus b over x minus 1 plus c over x minus 1 squared. To clear out your fractions, you multiply by the common denominator, and the common denominator is this. So each and every term, if you're going to multiply to one term, they all get multiplied by the same thing. X times x minus 1 squared. Okay, so what's happening is these denominators are gone. Okay, that leaves me with x plus 2 equals, these two x's are gone. That leaves me with a times x minus 1 squared. Then one of these is gone, so that leaves me with plus b times x minus 1. Then plus c times, okay, the x squared, x minus 1 squared is gone, so that's c times x. So let's distribute. Okay, so a times x squared minus 2x plus 1 plus bx times x minus 1 plus cx. Distribute some more. X plus 2 times ax squared minus 2xa plus a plus bx squared minus bx plus cx. Okay, then now you are going to group like terms together. So x plus 2 is still the same thing on the left. You have two x squared terms, so group them together. Okay, so those are gone. You have one x term, 2 and 3, so put those together. I'm going to write a positive 2x, an addition of negative 2xa minus bx and plus cx. Those are gone. And then you have 1a left over. Okay, so drop that down. Now, what are we going to do? These two have x squared in common. These have an x in common. So those are the ones we will factor out. Drop this down, take out the x squared. You're left with an a plus b. Over here, you will take out a positive x. Yes, always factor out positive x. You're left with negative 2a minus b plus c, and then drop down your a. Okay, so as you can see on the left-hand side, there is no x squared term. So that's 0 x squared term plus 1x, and then the constant's 2. So when you write the system, you have a plus b equals 0 because 0 is the constant for x squared. Then the next one, you have 1x, so that means negative 2a minus b plus c equals 1. Okay? Then your constant, a is 2. Well, if I know a is 2, then this is 2 plus b equals 0. That means b is negative 2. So a and b are found. So now you just have to plug it back in here to solve for c. So negative 2 times a is 2 minus negative 2 plus c equals 1. This is negative 4 plus 2, that's going to be negative 2, plus c equals 1. So c is going to be 3. So those are the ABCs. Now that I know what they are, I can plug it back in here. A is 2 over x plus b is negative 2 over x minus 1. C is 3 over x minus 1 and quantity. And those are the final answer. Next one, it looks like we have something to the third power. So again, factor it out when possible. This is a difference of 2 cubes, and yes, you are expected to know how to factor the difference of 2 cubes. So if you don't remember, please do look it up. So it's going to be a minus b times quantity of a squared plus a times b, so that's going to be 1x, plus b squared, that's going to be 1. So that's a factor. This has a non-repeating linear and non-repeating quadratic. So based on your formula, okay, now if you have to look back, please do look back at your notes. You're going to now have to merge 2 concepts with 1. So now this is going to be a over your linear plus the formula said bx plus c over x squared plus x plus 1. Okay. So now, just like the previous one, we are going to try to clear out your fractions. So I'm going to write it back again so that way I have space, okay? So 5x plus 2 over x minus 1 times x squared plus x plus 1. We have to find ABCs, so these will be equal to one another. Okay, so x squared plus x plus 1. So to clear out fractions, we will multiply it by a common denominator. Okay, so I'm going to write it all over so that way you are clear of what we are trying to accomplish. Okay, it's a lot to write. Okay, so that means these denominators are gone. So I'm now left with 5x plus 2 equals that, and that is gone. So now I'm left with a times x squared plus x plus 1. These trinomials are gone. So now I'm left with bx plus c quantity times x minus 1. So now by distribution, slowly, I will have ax squared plus ax plus a. Now this is going to be distribution, so bx times that is going to be bx squared minus bx plus cx minus c. Group like terms together, so all my a squares go together, plus bx squared So those are squares, plus ax minus bx, or plus a negative bx, plus cx, so those x's are gone. I have constant a minus c. Okay, factor out like terms. So 5x plus 2 equals like terms is x squared. So now you have a plus b. Over here, like terms x. So you have a minus b plus c. This one, this is your constant. Group them together. You don't have any square terms. So 0x squared plus 5x, and the constant is 2. So what you are going to do is take 0 equals a plus b. Then you're going to take 5. You're going to set it equal to a minus b minus, plus c, because this right here has a leading coefficient of 5. And then your constant is 2. So 2 equals a minus c. Well, this one, as you can see, I need to solve for a, b, and c. So what I'm going to do is I'm going to solve this carefully, right? Since I know, okay, so since I know a plus b equals 0, you can do either way. You can go, hey, a can be negative b or b can be negative a. It's really up to you. So since a is negative b, I know what that is. So I can go over here. I can go, well, since a is negative b, I can plug that in, right? 5 equals negative b minus b. Well, that's really not helping me, right? Because remember, I can only solve if I have the same thing going. What if I go, instead of doing a is negative b, can I go b is negative a? Okay, was that going to help me solve? So 5 equals a minus, now I see a b as negative a. Whoa, I have a c. C has a relationship as well, right? What if I go, well, c is, right? All I do is move it over. See, if I move the a over, okay, this is negative c equals 2 minus a. That means c equals negative 2 plus a, which is really a minus 2. I can go in and replace c with that. So plus, okay, every time I see a c, I put in a minus 2, a minus 2. So that's how you kind of need to do to solve this. So a negative a and a negative a is now 2a, positive 2a, plus another one that's going to be 3a. So 3a minus 2. Add 2 to both sides. So this is going to be 7 equals 3a. And then a is going to come out to be 7 over 3. So I got one letter. If I know a, I can find b. b is negative 7 over 3. Voila! If I know a, I also know c. c is negative 7, positive 7 over 3 minus 2. Common denominator tells me I would need to make this into a 3, so that's a 6. So 1/3. C is 1/3. Voila! Okay, so now I have a, b, and c. Let's plug it back in here and box it up, okay? A is positive 7 over 3. That's my number. My denominator is that, plus b is negative 7 over 3x. C is 1/3. All over your quadratic, non-repeating quadratic, that is. Okay, and that is, my students, the beautiful answer for decomposition. All right, we have one last one. Okay, this is probably repeating quadratic, right? We have to kind of give you example all the cases. So since the bottom is already factored, I don't need to worry about it. Okay, I don't have to factor the top. I'm gonna leave the top alone. So the formula for repeating quadratic is ax plus b over the first one, which is x squared plus 4, plus cx plus d over x squared plus 4, and then quantity. Okay. Now I'm gonna multiply by the common denominator, so that way I can clear out my fractions. And I'm not going to write it over again because this one I didn't really have to do a lot of factoring, so there wasn't any work prior to this. Okay, so x squared plus 4 times, square. I don't have to write it out. It's just square. Okay. So with that said, as you can tell, one of this is canceling. So I am left with, and those are both canceling. So x to the third plus x squared equals ax plus b times, I still have one left. Then over here, as you can see, both of these are canceling. All right, let's distribute. X to the third plus x equals ax to the third plus 4ax plus bx squared plus 4b plus cx plus d. Let's put all the third power together. So there's only one, so that would be nice. All the x squared together. There's only one, so that's also nice. So those are gone. I have two x's, put them together. 4ax plus cx, and then we have constant 4b plus d. Well, since we only have, oops, I forgot the square terms. These are all square terms. Since I only have one x to the third, leave it. Since I only have one x squared, leave it. I'm going to factor out an x here. So that means 4a plus c. Then these are just going to be grouped together as 4b plus d. Okay? Okay, here we go. Then, since this is a 1, this is a 1, there's 0x, and then 0 constant. Okay? So what that means is a equals 1. B also equals 1. 0 is now equal to 4a plus c. And 0 also equals to the constant 4b plus d. So since I know a, since I know b, I can definitely go and find the rest. For a is 1. So this is 4 plus c. That means c is now -4. Woo, woo, woo. Same thing over here. 0 equals 4 times b is 1. That means d is now that. So d equals -4. Okay. All right. Let's put it together so we can box up our answers. So the decomposition is a is 1. So it's going to be x. B is 1. So plus 1 over x squared plus 4. Plus c is -4. X plus -4 all over x squared plus 4, and then the quantities on the bottom. So that is how we decompose. All right, guys, this is the final recording. Section 12.1, the title is called Sequences. So we are going to start out with defining some of these vocab, and then we can move on to a few examples on the bottom, okay? Okie dokie, here we go. Sequence is a function whose domain is the set of all positive integers. Is the set of positive integers. Series is the sum of all the terms of a sequence. Is the sum of all the terms of a sequence. All right. So we have the word terms. Terms are the numbers in the sequence. Terms are the numbers in the sequence. Factorial symbol. Usually we use this symbol right here. So n factorial, meaning that it's n times n minus 1 times ... times 3 times 2 times 1. Okay, so if I don't want to use the dot, I can use parentheses to represent multiplication. For n to be greater than or equal to 2. Because there are some special things with factorial. If n is not 2 or greater, like n is 1. So if it's 1 factorial, it's really 1. Also, if it's 0 factorial, it's, guess what? It's not 0, it's also 1. Okay. Now, so factorial, it's really factorial is going back to probability. Okay. So if you have 0 factorial, that really means how many ways, okay, how many ways can you arrange 0 items? Well, there's only one way, okay? There's one way to arrange 0 items. It's just because what happened when we have nothing to arrange, okay? There's nothing. Then 1 factorial really means how many ways can you arrange 1 item? Well, one way to arrange 1 item. So for example, you have 1 book. How many ways can you arrange 1 book on the shelf? It's just one way. Now, what if you have 2 factorials? Okay, so what if n is 2? This means you have 2 times 1, which is 2. Okay, that means how many ways can you arrange 2 books? Well, there are 2 ways. Okay, so you got 1 book go in the front, let's call it book 1, and then book 2 go in second. Or, that's one way. Or you can arrange it, book 2 go in the front and book 1 go in the back. So there are 2 ways of arranging it. So n factorial, think of it as how many ways you can arrange items if you are in probability and AP Stats class. Okay, but in here, we're just gonna calculate the number. So what if I ask you to find, like, for example, i.e., 8 factorial, okay? 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's a huge number, okay? 8 factorial is a ginormous number. It's 40,320. So that's what 8 factorial is, okay? So how many ways can you arrange 8 books? Take a wild guess. You're right, 40,320 different ways, okay? Now, so here is a question for you. Do you think 10 to the 100th power, which is called Google, is it bigger than 70 factorial? Okay, so the next time I see you, you can give me an answer. And if you have a graphing calculator, is it possible for you to do 70 factorial in your calculator? Okay, do you even know where the factorial symbol is? Okay, so try to figure that out with your calculator. If you don't know where the factorial button is, you can totally ask me in class, okay? Next, recursive formula is a sequence, that requires you to find the values of all previous terms in order to find the value of a sub n. Okay, so recursive formula is a sequence that requires you to find the values of all previous terms in order to find the value of a subscript n. What that means is that if you want to find the 5th term, that means you have to find the first 4 terms first. Okay, so that's what that means. Fibonacci sequence. Okay, it's really well known. Most movies that you watch that has a little bit math involved, they always bring this up. Okay, is a series of numbers. Is a series of numbers. Starting with 0 and 1. So, comma, starting with 0 and 1. Where a number is found by, adding up the two numbers before it. Okay, so Fibonacci sequence is 0, 1. Okay, for you to find the third number, it will always start with 0, 1. And it will always be the same sequence because it has a name. It has a Fibonacci sequence. That means it's created or was created by Fibonacci. So the third digit is going to be 1. The fourth number is going to be 2. Remember, you're always adding the first two numbers. So the next one is 3, the next one is 5, the next one is 8, the next one is 13, and so on and so on. Okay? Summation notation is a concise way to express the sum of a sequence. So let's say that I'm going to give you a sequence such as this. So IE, okay? IE. A1 plus A2 plus A3 plus, skip a few, plus A sub n, okay? Mathematicians were quite lazy, I would say, right? Because we just want to think and we want to come up with creative ways to do math. So instead of writing it out like 100 times, that's a waste of time. We don't have time to do that. We need a shorter way to write that out. So what's happening is the bottom number right here. Okay, so I want to start with the bottom. And first let's talk about how do we write this summation notation. Summation notation is like an E, like that. Do an E like that, okay? The bottom number, the bottom number is, you're telling me what you're starting with, okay? So K equals 1. That means my first term is 1. Then on the top is where it ends, okay? So this is where it ends, this is where it begins, okay? And then on this side number here, which I'm gonna write in rainbow, is what do I do to get all of them? Okay, so A subscript K. So if K is 1, then that's my first term. If K is 2, then that's my second term. If K is 3, then that's my third term. If K is n, then that's my nth term. So this is a quicker way to express the sum of a sequence. Okay, let me give you another example. So another one, let's do 1 square plus 2 square plus 3 square plus 4 square plus, skip a few, 9 square. Okay, this one, we know where it ends. So I'm out of space there, so I'm gonna go over here. So how do I write the summation of this sequence? We write the big capital E looking symbol. I will start with K equals 1. No, K doesn't always have to be 1. K can be 0. K can start a different number, okay? When K is 1, okay, and then that's my beginning value. Now, where do we end? We end at 9. So we don't have n on the top because now we know where we end. The last number is 9. Now, how do I get each digit? What happened is when K is 1, I would have 1 square. When K is 2, that's my second term, right? When my first term is 1. So what's happening is, hey, what can I use? Over here is sort of the formula. So what you just do is just write K squared, because each value of K you put in, that will give you each term until I go to K equals 9. Then that is my last term. Hence, this is the end of it. And this is the beginning. Okay, so you get the end and they get the beginning. Properties of sequences. Okay, we have 4 of them. So here we go. If the set of A sub n and the set of B sub n are 2 sequences and C there you go, and C is a real number, then here we go. Case number 1. The summation of k equals 1 to the nth term of C times A subscript k equals, so if I give you the summation of starting at k equals 1 and it ends at n term, and C, according to this definition here, C is a real number. That means it can be anything it wants to be, okay, and times A subscript k, then this is the same thing as just saying C times A subscript 1 plus C, whatever C is, times A subscript 2 plus, skip a few, C times A subscript n, okay, which is the same as taking out your C, because that's what C is. They all have C in common. It's just that real number. Then we can just go ahead and add A1, A2, skip a few, A sub n, okay, so those are equivalent. Well, if those are equivalent, that is also equivalent to the summation, again, k starting at 1. It's the same thing as adding all the A's first, then multiplying by C, okay, and we end at nth, and it's going to be A subscript k. So what this is saying that, hey, if I have C, the summation of C, A subscript k is the same thing as saying that do the summation of A subscript k first and then times it to C, okay? 2. The summation starting at k equals 1, it ends at nth, of A subscript k plus B subscript k, okay, in quantity. Then this is the same exact thing as if I were to break it up as 2 summations, okay? So it has this property. So these are the rules. So if you have the summation of A subscript k plus B subscript k in quantity, then it's the same thing as I can break these out, okay? Number 3, I'm just going to write it over here because I'm kind of out of space. If I have the summation k starting at 1 to the nth power quantity of A subscript k minus B subscript k, it's very similar to your addition. I can break this up into summation of k equals 1 to the nth of A subscript k, take away summation of k equals 1 to the nth of B subscript k, okay? So the addition of summation and the subtraction of summation, you can break it up. And 4, our last property of the sequences, if I have the summation of k equals 1 to the nth power of A subscript k. This is, oops, my bad, we don't start at 1 anymore. Of things that don't start at 1, okay? Like j plus 1, okay? And j, it's whatever it wants to be. And then we're going to define j in a little bit, whatever positive number, I should say, that it wants to be, okay? So again, the summation of k equals j plus 1. What this is really meaning that I don't want it to start at the value of 1. Then I can turn it into, what if I wanted to start at 1? In a little bit, we are going to do problems that things don't start at k equals 1. And usually we want it to start at 1 because it's easier, right? but sometimes that doesn't really happen. Okay, so how do we bring things back so that way it can start at 1? Then here's the rule. We will do summation of a subscript k starting at 1 to n minus the summation of k equals 1 of a subscript k to j. Okay, and what on earth is j? Where j is greater than 0 and less than n. Okay, so let's say n is 9. Okay, that means j can be 4. So that means this is really starting at 5, right? If j is 4, well, I don't want it to start at 5. Okay, I want to count starting at 1. Then I can start from 1, okay, to 9, and then take away, oops, I didn't finish writing. This is k equals 1. Okay, take away 1 to 4. Okay, so that gives me 5 to 9. That's all that is. Okay, and if this is confusing, it's totally okay. We will do problems, and that will be using these, just like all of our definitions. At first, it sounds scary and it looks scary and it sounds confusing, but it's just a language. Once we put it to use, they will make a lot more sense. Okay. All right, formulas for sums of sequences. So we have 4, okay? These 4 you should really know if you want your life to be easy, okay? Summation, I know my summation symbol is quite ugly. I think your book does a better job like that, but I just can't do it by hand. So I'm just writing E, really. So formula for sums of sequences. That means I'm gonna add up all the terms now. So starting at 1. K equals 1 to the nth power. If you just have C, then what happens if you just have C and you want to add up all the C's? But just really what that means is C plus C plus C dot 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 plus C. That means you have C times n. Okay, what is C then? C belongs to any real number. C can be 1.5, 1.2, whatever C wants to be. Okay, 2. Let me just give you a quick example, i.e., okay, summation k starting at, let's say, 1 to 4, okay, and C is any real number, so let's pick 2. So that means, what do I do with that? What does that mean? This means when k is 1, okay, my first term, when k is 1, it doesn't really matter because I just have 2. The next sequence, when k is 2, I just have 2. The next one, I have 2. And the next one, I have 2. Well, the summation, I have 4 terms because it ends at 4. The summation means I need to add all of these. Okay? So when I add them all up, it's just really 2 times however many terms I have. Okay? So this is n right here. So that's why this is 8, or C times n. Okay? So that's how they come up with that formula. All right, next. I have a summation starting at 1 to the nth, and I have k, okay? So, when k is 1, then my first term would be 1. When k is 2, then my next term would be 2, okay? So when k is 1, it's 1. When k is 2, then it's 2. When k is 3, then it's 3. And so on until it's nth term. Right? That's my dog wanting to come in and I just can't pause right now. So what's the formula if I want to add them all up? You're not going to sit here and add, if n is 100, you're not going to sit here and put this together. Okay, if n is 500, you're not going to sit here or on your calculator do 1 plus 2 plus 3 plus 4 plus 5 500 times. So you want to come up with a formula. So the formula is n times n plus 1 all over 2. So i.e., okay, if I have the summation of k starting at 1, that's n is 10, and then I just have k. So what this means is I have 1 plus 2 plus 3 all the way to plus 10, right? So instead of just sitting here and adding it all together, you can go, well, 10 times 10 plus 1 all over 2, which is 10 times 11 all over 2, which is really we can reduce those. That's really 5. So 5 times 11 is 55. So that's kind of how we think of it. All right, 3. The summation starting at 1 to the end, and what if you have k squared? So the first term, k squared, is still 1. Second term, 2 squared is 4. Third term, when k is 3, 3 squared is 9, plus dot dot dot, plus n squared. So just like number 2, you're not going to sit here if n is like 99. You're not going to sit here and do it 99 times in your calculator. So you want to come up with a quick formula so that way you can come up with the sum. The sum means the final answer of all of that. So that's the formula. There will be a class in college that you will take, or if you want to take, I should say, if you're going to be a math major, that will prove all of these or will help you explain why we come up with all of these. Well, I think that's even in calculus. Maybe next year you will. Okay. The summation starting at 1, again, k equals 1 to n. What if I have k to the third? So when k is 1, 1 to the third is 1. When k is 2, 2 to the third is 8. When k is 3, 3 to the third is 27, and so on, plus n to the third. Well, all right, here we go. Formula for this is going to be n times n plus 1 all over 2. Well, that looks too much like k, right? So that can't be right because this is k to the third. So what's happening is we're going to take the quantity of that all and we square it. Okay, so that is the formula to the third power.